Hi, today we are here to show you how to do the bubble cap distillation experiment. Bubble cap distillation tray was the most used device through 1940 up to 1950. It was used for the separation of mixture at atmospheric pressure in a continuous operation.
The trays consist of a riser with a cap on the top. The bubble is flow through the cap with contacts. The main advantage of this device is that we can assure positive total contact with the bubble and the liquid through the riser. And the main drawback of this device is due to the complex design of the cap.
Before going in the details of the process and operating procedure, we must know about the safety and the personal protect equipment for this device. First, we have to wear a lab coat. Second, the helmet. Third, proper shoes and gloves and a face mask.
The main objective of the current experiment is showing the separation of a mixture at atmospheric pressure in a continuous operation, and the mixture is ethanol and water. We have three main sub-objectives. The first one is plotting the temperature and composition profile of the column. The second one is determining the number of the equilibrium trays, and the last one is calculating the morphy efficiency of the trays.
Okay, here is the overall view of the experimental setup. Here we show the main part of the equipment. First, we have the riser with the trays inside. At the bottom, we have the mixture vessel with 50% water and 50% ethanol.
This is the main control board of the experimental setup. There are several sensors for showing the temperature of the trays. This sensor will show the temperature of the boiler, and with this valve we can control the flux. While doing the experiment, we can check the process of the experiment, the flow of the experiments by the software.
Here we have our main heating valve. It's for the steam. So when we come to open this valve, we have to wear these gloves and to open the main valve. Also, here we have the cooling water system to supply our equipment with the cooling water. And here we have the air valve. We need to make sure we open the air valve. So to supply the air to the pump.
To run the experiment, so as the first step, we have to open this valve completely. The next step is opening the vapor valve. Don't forget to wear this glove. Done.
Okay. After we open the valve, the steam valve and the water supply valve, we come here to the control panel to adjust the temperature of the boiler. So we adjust the temperature of the boiler from here. We make it increase until the 90 degrees Celsius. Okay, now we adjust the temperature of the boiler until up to 90 degrees Celsius to ensure the safety. Here we come to this main switch. It's for the flux. So the flux here with its total reflux when it's set at 0, and if I want to change it to the total offtake, I switch it to 1, and I can maintain the flow between total flux and total offset by using number 2. Okay. So after I switch the main switch for the flow to total reflux, we can observe that the temperature of the trace is start to increase.
As you can see, the temperature is still increasing. We should wait until the temperature becomes totally stable. The stable temperature profile means that the steady state is achieved, and we should consider this temperature profile. Now we should take out the sample for the further analysis. For this purpose, we have to use this one. As you can see, it has a label according to the number of the tray. This one is TI4, so I have to take the sample from this tray. And for the safety issue, we have to also wear the glasses. So we insert this one, take out some sample, and keep it for the further analysis.
After we adjust the flux from total flux to total update, we come here to this green bar to take the sample of the distillate, just from this green bar.
We're taking samples from all the trays and also the upside of the column. We have to do the same for the bottom sample of the column. Same as previous, we can open this valve and collect the bottom sample.
After we collect the sample, bottom sample and top sample and the sample from each tray, we need to measure the reflux index of each sample to know the composition of the sample. Here we use this reflectometer to measure the reflux index. First, we need to pour a very small amount of our sample here, just simply, and close it down and just press stop. Now, as we can see, it's measuring.
As you can see, the value is shown here, is displayed here, but we cannot use this value directly for predicting the unknown composition of the samples. So what can we do? The thing is that we have to plot the calibration curve as mentioned in the appendix A of your lab manual. Based on this table, a set of mixture containing ethanol and water with different range of composition between pure water and pure ethanol must be prepared. In the next step, for each mixture, the reflective index must be obtained, must be read, and after that we have to plot the calibration curve. We should obtain the equation based on the calibration curve, and by using that equation we can predict the unknown composition of the sample.
Now we come to the last part, is the shutdown part. For the shutdown, first we need to decrease the temperature until it reaches the 0 Celsius centigrade, and we can come here to the steam valve and carefully close the valve until it's totally. After we close the steam valve, we come to the water system. We just close this cooling water after we ensure that the temperature is reached the minimum temperature. Okay, after we close the main valve and the water supply valve, we come to switch off the power supply.
Thank you very much.
Very much.